Assalamualaikum and good evening to our lecturer Dr. Azlan and my fellow friends. Today we will like to present our assignment. The title is Quadrature Amplitude Modulation QAM. This is our group members. My name is Nur Nasrin Shazwani binti Haznan. Next is Kong Tian Chuan, Azra binti Azharuddin and Adam Haris bin Fazli. Introduction. The modulation technique quadrature amplitude modulation QAM is defined as the combining of phase and amplitude modulation of a carrier wave into a single channel. In other words, QAM doubles the effective bandwidth by changing both the amplitude and phase of a carrier wave while transmitting data. Quadrature carrier multiplexing is another name for QAM. Why QAM is called so? Because QAM is a signal in which two carriers shifted in phase by 90 degrees, such as sine and cosine. They are modulated and combined as a result of the 90 degrees phase difference. They are in quadrature and this gives rise to the name. That's all from me. Next, I will pass this presentation to the next presenter. Thank you.
Hi, my name is Kong Tian Chuan. Now, I would like to present of the basic quadrature amplitude modulation IQ circuit. And these two diagrams are the modulator and demodulator circuit. So, there will be modulators and demodulators in any system that employs quadrature amplitude modulation. The QAM modulators and demodulators must be able to modulate the carrier with the in-phase and quadrature components of the baseband signal. Moreover, the QAM modulator is based on the basic QAM theory, which states that there are two carrier signals with a phase shift of 90 degrees between them. These are then amplitude modulator with the two data streams, known as I or in phase and Q or quadrature. These are produced in the baseband processing section. Furthermore, the QAM demodulator is essentially the opposite of the QAM modulator. The signal enter the system are split and each side is fed into a speed mixer. The in-phase local oscillator signal is applied to one half and the quadrature oscillator signal is applied to the other. So, there are three methods to perform QAM simulation. Method 1. Declaring two impulses of different frequency. Method 2. The use of a filter during the demodulation step. And method 3. The use of wave read, which reads two voice signals to modulate and then saves the actual voice signals using wave write after demodulation. Okay, now I will pass to Adam to the demonstration. Thank you.
Assalamualaikum dan selamat sejahtera. My name is Adam Haris bin Fazli. Today I'm going to talk about the result and the simulation for our project, that is the QAM. Okay, this is the plot diagram for our QAM over here. The first one over here, we will generate a parameter for the random integer generator. Then it will go to the rectangular QAM modulator baseband. This one will modulate the input signal using the rectangular quadrature amplitude modulation method. Then it will send the signal over here, go to the AWGN channel to add the white Gaussian noise to the input signal. This input signal can be real or complex. So the signal over here, the noise signal, will send to the rectangular 16 QAM demodulator. Then over here we'll go to the error rate calculation, and it will take the previous data over here to compute the error rate of the received data by comparing it to the delay version of the transmitted data. So over here, constellation diagram number 1, it will generate the output for the rectangular QAM modulator baseband over here. Same goes this one. The constellation diagram will generate an output for the AWGN. So if we run the simulation, as you can see, this is the constellation diagram for number 1 over here, the output for the QAM modulator. This is the trajectory for the signal over here. Okay, for the second diagram over here, as you can see here, the noise signal over here is more scattered than the previous one. Then if we press over here, you can see the trajectory of the noise is more scattered. Okay, that is it. Okay, this is the coding for our project for the QAM. This line number 4 is for audio read test2.wav. This is to store the audio in our coding. Then line number 5 and line number 6 is to the maximum value of the audio sample and the medium value of the audio sample. And then it will generate the step size to calculate, that is to maximum value minus the minimum value and divided by 12 over here. Then we use the QAM modulation over here to modulate the constellation over here. Then if we run the simulation, we will get the output signal over here. For this one, this is the original audio signal that we transfer. Okay, as you can see, it will overlap the two signal. Then figure number 3, it will this is the quantized audio signal. This is the combination of the two audio signal. This is the output for the constellation, as you can see here. For next is this is the modulator signal, as you can see here. And last one, this is the received audio signal. Is very similar to the original signal over here, as you can see. Okay, the advantage of the QAM. There are 3 key advantages. That is, the QAM has a high noise tolerance, therefore the noise interference is minimal. Next is the QAM allows for a high data rate, so that the carrier signal can carry the required number of bits. As a result, it most commonly seen in wireless communication system. The last one, the effectiveness of the bandwidth of the QAM is double. The next one is the disadvantage of QAM. The first one is the change in the amplitude are vulnerable to noise in the QAM. It is also difficult for the receiver to decode the signal correctly in the higher order QAM format. In other words, the noise immunity is lower. The last one, the constellation point of the higher order QAM format are closer together, making them more vulnerable to noise. Now I'm going to pass to next presenter, that is Azra. Thank you.
Okay, thank you. Next, I will continue for my part. In conclusion, ongoing towards IoT and Industry Revolution 4.0 era, QAM modulation technology is frequently utilized for achieving improved noise spectral efficiency as well as transferring faster data rates in a restricted frequency spectrum. The advantage of modulation technique is especially obvious in mobile communication and satellite communication when bandwidth resources are limited. Other than that, This work also creates a QAM digital transmission system with analog source and perform system construction and performance verification using simulation platform. The simulation results suggest that the analog signal may be conveyed effectively while allow for some distortion in the system. At the end of this assignment, we are able to get the opportunity to learn some of the state-of-the-art technologies in the digital communication system at our own initiative. Okay, that's all from me. Thank you.